GPT-4 scores 90% on MMLU. Your local Llama 3.18b scores 73%. Those are big numbers, they look like grades on a test. But here's the thing nobody tells you, 6.5% of those MMLU questions contain errors. The virology subset alone, 57% of questions have mistakes. A third of them are completely wrong. The model may have already seen the answers during training. And the top 5 frontier models are all clustered within 2% of each other. The benchmark literally cannot tell them apart anymore. The entire foundation of how we measure AI capability is cracking. This video is about why benchmarks are broken, what's replacing them, and how to actually tell if a model is good without getting fooled by a number. Before we can understand what's broken, we need to understand what these benchmarks actually measure. Because every benchmark tests something different, and none of them test what you probably think they test. Let's start with the big one, MMLU. Massive Multitask Language Understanding. Released in 2020 by Dan Hendricks and team. It's 15,908 multiple-choice questions across 57 subjects, from abstract algebra to international law, virology to nutrition. 4 choices each. That's a 25% chance just by guessing. Scoring is simple, few-shot accuracy. You show the model a few examples, give it the question, and see if it picks the right letter. GPT-3 scored 43.9% when MMLU launched. Human domain experts hit about 89.8%. For years this was the gold standard. Then there's HumanEval, 164 handwritten Python problems. The model gets a function signature and a docstring and has to generate code that passes real unit tests. Pass it K, the probability that at least one of your samples passes. Human baseline is 96%. GPT-4 hits 87%. Claude 3.5 Sonnet hits 92%. And GSM-8K 8,500 grade school math word problems. 2 to 8 steps each. Chain of thought reasoning. Also from OpenAI, also 2021. GPT-3 got 58%. Now models are hitting 97%. 3 different benchmarks. 3 different capabilities, knowledge, coding, math. And all 3 are now so saturated that the scores are basically useless for comparing the best models. Now here's where it gets uncomfortable. Every one of these benchmarks has a fundamental problem. The answers are on the internet. Think about how training data works. Companies scrape the entire web, Common Crawl, GitHub, AR14, Reddit, Wikipedia. Every paper about MMLU, every blog post breaking down HumanEval results, every discussion thread about GSM-8K, all sitting in the training data. Here's what OpenAI itself acknowledged in the GPT-3 paper: GSM-8K contamination was real. They tried filtering it out using n-gram overlap detection. But that catches exact duplicates, not paraphrases. It catches what is 7 times 8, but not calculate the product of 7 and 8. The impact is massive. When a model has seen the test data during training, scores can inflate by 5 to 15% purely from memorization. Not from genuine capability improvement. And here's the scary test: change the prompt format from multiple choice to open-ended generation. If the model's score collapses, it wasn't reasoning, it was pattern matching. Detection methods exist. N-gram overlap analysis. Canary strings, secret markers embedded in benchmark questions. Membership inference. But none are foolproof. Once a benchmark is published, it's effectively contaminated. The only truly clean benchmark is one that doesn't exist on the internet yet. And that's where the field is going. So if static benchmarks are contaminated, what do we use instead? Enter the Chatbot Arena. Launched in April 2023 by LMSIS at UC Berkeley. The idea is brilliantly simple: you give 2 anonymous models the same prompt. They respond side by side. You, the human, vote on which answer is better. You don't know which model is which. No multiple choice. No canned questions. Real users, real prompts, real preference. After more than 1 million votes, the system uses a Bradley-Terry model to calculate ELO ratings, same system as chess rankings, adapted for AI. Bootstrap confidence intervals give you error bars. The result is a leaderboard that's remarkably resistant to gaming. As of today, Claude 4 Opus and GPT-5 variants top the chart. But here's the story I love: DeepSeek R1, a free, open-weight model, broke into the top 10. That was a genuine shock to the field. An open model competing with proprietary giants on pure chat quality. Now, it's not perfect. The users who vote on Arena are self-selected, they're AI enthusiasts, not a representative population. Users choose their own prompts, which can be gamed. And Arena only measures chat quality, it doesn't test factual accuracy, coding ability, or deep reasoning. But here's the key advantage: it's much harder to game than a static benchmark. Every prompt is fresh. Every vote is human. You can't memorize the test set because there is no test set. But chat quality isn't everything. What about real work? That's where SWE-bench comes in. Released by Princeton in 2024, SWE-bench tests the thing that actually matters for developers: can a model fix a real GitHub issue? The model gets the full codebase snapshot and a bug report. It has to produce a working patch, actual code changes, that passes the project's real unit tests. 2,294 task instances from 12 major Python repos: Django, Flask, SymPy, and more. This isn't toy problems. These are real open source issues that real humans filed. The results are sobering. Claude 4.5 Opus leads at 76.8% with high reasoning enabled. That's close to human level, estimated around 80%. Gemini 3 Flash scores 75.8%. GPT-5 Codex at 72.8%. But look at the open models. DeepSeek Coder v2 scores around 40%. Claude 3.5 Sonnet, just a generation ago, hit 49%. The gap between proprietary and open models is real here. SWE-bench is the hardest major benchmark right now, and it's the one that actually measures productivity. This is the prototype for the future of evaluation. It doesn't test what a model knows. It tests what a model can do. So where does this leave us if you're running models on your own hardware? Let's cut through the noise and look at real numbers. The Qwen family from Alibaba, Qwen 2.5-72b, is the best open source all-rounder right now. 85% on MMLU, 80% on HumanEval, 96% on GSM-8K. It runs on consumer hardware with quantization. The 32B version gives you 82% MMLU for much less RAM. Even the 7B hits 75%, which is remarkable for a model that fits on a Raspberry Pi with the right quantization. Llama 3.1405b from Meta reaches frontier territory: 88% MMLU, 89% HumanEval, 97% GSM-8K. That's GPT-4 level on static benchmarks. But you need serious hardware for it. The 70B version is the sweet spot: 86% MMLU, runs on dual GPUs. The 8B gets 73% and runs on your laptop. DeepSeek V4 Pro hits 91% MMLU, currently the highest for any open model. DeepSeek R1 with its chain of thought reasoning scores 90% MMLU and 95% GSM-8K. The reasoning really shines on math. Here's the takeaway: static benchmark scores are no longer a differentiator for frontier models. But for local models, they still tell you something useful, especially when comparing within the same size class. A 7B scoring 75% on MMLU is impressive. A 7B scoring 60% is struggling. The number matters, but you have to read it in context. The biggest gap? SWE-bench. Proprietary models are still roughly 2x better at real software engineering. That's where the actual capability difference lives. So how do we fix evaluation? The field is converging on 6 trends. Let me walk through them. Trend 1: Agentic benchmarks. This is the big paradigm shift. Instead of asking a model a question, you give it a task and see if it completes it. SWE-bench is the prototype. Web Arena tests web-based agents. OS World tests desktop OS agents. Mint tests tool use. The core idea: evaluate what models do, not just what they know. Trend 2: Living benchmarks. LiveBench, from ICLR 2025, generates fresh questions every month from recent math competitions, R14 papers, and news articles. No static test set to memorize. 7 categories, 23 tasks, objective scoring. If the questions don't exist on the internet, the model can't train on them. Trend 3: Difficulty adaptive testing. MMLU Pro makes questions harder with more answer choices. AIM and AMC are competition-level math that even top models struggle with. Frontier math from Epic AI contains problems that have never been solved before only AI models get to try them. These benchmarks keep raising the bar as models improve. Trend 4: Human preference. Arena-style evaluation. It's imperfect, we covered that. But it's the hardest to game, and that matters. Trend 5: Task-specific expert benchmarks. Medical QA with MedQA and PubMed QA. Legal reasoning with LegalBench. PhD-level science with GPQA. Finance with FinanceBench. As models get deployed in specific domains, evaluation needs to follow. And Trend 6: Multimodal evaluation. MMLU for college-level vision language tasks. MathVista for visual math reasoning. Video MME for video understanding. Models aren't text-only anymore, and our evaluation shouldn't be either. The end game? Continuous evaluation pipelines where fresh data flows in automatically. Benchmark as a service. Cost versus capability normalized into a single metric. And behavioral testing, not just scores, but systematic probes of model behavior. Let me pause on one concept that explains why this matters: saturation. When MMLU launched in 2020, GPT-3 scored 43.9%. The best models in the world couldn't get half the questions right. By 2023, GPT-4 hit 86%. By mid-2024, GPT-4o, Claude 3.5 Sonnet, and Llama 3.1405b all hit 88 to 90%. Today, the top models exceed 90%. The problem isn't that 90% is bad, it's that the gap between the best model and the fifth best model is less than 2%. That's statistically meaningless. The benchmark has hit its ceiling. It can no longer differentiate. MMLU has been partially phased out in 2025. Replaced by MMLU Pro with harder questions and more options. But the same thing will happen again. Models will catch up. The benchmark will saturate. We'll need another replacement. This isn't a failure of the benchmark designers, it's a feature of how fast this field is moving. Benchmarks that took years to build are obsolete in 18 months. The only sustainable approach is a benchmark that evolves as fast as the models. That's why living benchmarks and agentic evaluation aren't just nice ideas, they're existential requirements for the field. One quick practical detour for the local model community. You don't have to trust model cards. The LLM Evaluation Harness from Eleuther AI is the standard tool for running benchmarks on your own hardware. Pip install LMEval and you're off. You can run MMLU, HumanEval, GSM-8K, any of the major benchmarks on your own machine with your own quantized models. The results are often eye-opening. A model card says 73% on MMLU. You run it yourself on a 4-bit quantized version. It scores 68%. The quantization cost you 5 points. Now you know. For a quick vibe check, LiveBench updates its questions monthly. Run your model against the latest batch. If the score is within a few points of the model card, your quantization is solid. If it drops significantly, you need to adjust. This is the single best thing you can do as a local model user. Stop trusting numbers on a page and run them yourself. Let me pull this all together. MMLU, GSM-8K, and HumanEval are no longer reliable for comparing frontier models. They're saturated and contaminated. If a model card leads with MMLU score as its main claim, be skeptical. Chatbot Arena ELO is the best overall vibe check. It's harder to game, grounded in human preference, and updated constantly. But it only measures chat quality, not coding, not factual accuracy, not reasoning. SWE-bench is the most meaningful capability benchmark right now. Real task completion, real value. If you care about what a model can build, this is the score to watch. Living benchmarks like LiveBench are the future. If the questions exist on the internet, the model will train on them. The only sustainable evaluation is one that generates fresh data. And for local model users, check LiveBench and Arena before trusting a model card. Run LLM-Eval yourself. The only score you should fully trust is the one you generated. If you run local models, here's your homework this week. Don't just trust model cards. Go to livebench.ai and check the latest rankings. Go to Chatbot Arena and vote on a few battles, your vote actually matters. And if you're feeling ambitious, run pip install LLM-Eval and benchmark your own model. Comment below, what benchmark do you actually trust? I want to know. Because this conversation isn't over. The way we measure AI is evolving fast, and the score you see today might mean nothing in 6 months. Subscribe for more deep dives into how AI actually works under the hood. Thanks for watching.